Hello, hello, and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel, we talk about all things related to general chemistry. On this video, we're going to be learning all about dimensional analysis, or what I like to call the given and find method, and how we can use this as the foundation for how we will do all of our calculations moving forward throughout this chapter. Let's get started. So in this chapter, we're going to be learning how to do dimensional analysis and really use this as the foundation for how we're going to set up and solve problems from here on out. Having this foundation is really essential, especially when we get into those things like stoichiometry, but you'll see how we'll use the same concept moving throughout the rest of the course. And so remember, when we're making measurements, all measurements have a and a unit present. And so there's a lot of things we can do to manipulate these units within our calculations. So if we're multiplying two units together, that unit becomes squared. If we're adding the unit together, it remains as is. And if we divide by a unit, we can get 1. So centimeter divided by a centimeter gets us 1. And so using the units as a guide is what allows us to solve a problem through this idea of dimensional analysis, or this given and find system. And so what's really key here is understanding what are the relationships between the different units that you're trying to connect together or relate together. The conversion factor, like what we've seen on our metric system conversion tables before, it really tells us how much of each unit is equivalent to one another. And those conversion factors can be used to make these equivalent statements that we're going to plug into our problems. So for instance, if we say 1 inch is equal to 2.54 centimeters, we can write that as saying there's 2.54 centimeters for every 1 inch, or 1 inch for every 2.5 centimeters. And that's what we'll be plugging into these dimensional analysis setups. So when we're solving these problems, and I would go ahead and put a star on this slide or mark this one up as something that you're going to be using kind of like the holy grail when you're doing all your calculations here. We're going to arrange it so that our units are able to cancel out. And so whatever units I start with, those are my given units. I want to put similar units that are found in the conversion factor onto the bottom, like so. And that allows me to cancel out these units. And the find, the thing that I desire, would go up top. So the beauty of this is that if you have something that is not directly related through a single conversion factor, you can do multiple conversion factors to get that desired unit. And so here you can see where you have this multi-step approach. I always stress to my students, put the unit in first, and then add the numbers associated with that conversion factor to avoid putting it in the wrong place. Students sometimes get hung up on, should the one go on the top or on the bottom? And that really is dependent on where the units belong. So again, put your given units first. Whatever you're given, put that towards the bottom so they cancel. Whatever you're trying to solve for, put that at the top so you can end up with that unit remaining. Okay. And so let's look at this problem here. So it says we're converting from 1.76 yards to centimeters. Always ask yourself, can I solve for this in one step? And if the answer is no, we know we're going to need multiple strings put together. So in this case, I can't go directly from 1 yard to centimeters, but I do see a relationship between yards and meters, and then subsequently meters to centimeters. So this tells me that it's going to take 2 steps to solve this problem. So if we now start with our given, which is 1.76 yards, well, yards is our given unit. So that means in this first conversion factor, I'm going to put yards on the bottom. And again, I'm not putting any numbers in just yet. I'm just putting those units in. So yards on the bottom. On the top, I'm going to put my meters. And then I would be able to fill this out a little further, because now I'm ready to go to that next step. I want to get rid of meters. And so it goes on the bottom. And on the top, we would have centimeters. Now is the time that I want to fill in this information. I'm going to let the units drive where I put things. So the conversion that's listed on the paper or on the page says that 1 meter is equal to 1.094 yards. So I'm going to translate that into this conversion factor. So 1 meter, so 1 up top, is equal to 1.094 yards. And then I have to reflect back to my metric system, and I know that 1 centimeter is the same as 10 to the negative 2 meters. When I'm ready to put this in the calculator, again, remember, we're going to multiply across the top and hit the division symbol for anything that's on the bottom. So I would be saying 1.76 times 1 times 1. Those ones aren't necessary. Then I'm going to divide it by 1.094 divided by 10 to the negative 2. And so when I plug this in with proper sig figs, I end up with 160.877, etc., coming out of the calculator. I end up with 160.877 coming out of the calculator. However, with proper sig figs, we're only going to be looking at this given for our sig figs. I see that there's only supposed to be 3, and so my answer would end up becoming 161 centimeters. The reason we're not including those conversion factors as part of my significant figure count is because those are considered to be exact numbers, which means there is an infinite amount of sig figs. So our fewer sig figs is what's going to define the answer. So 3 versus an infinite, 3 is going to win. So our answer should only have 3 sig figs. Problem. It says we want to go from 30 milliliters to quarts. Again, I asked, do I know a direct relationship between one or the other? So from milliliters, I would first need to get to liters. And then from liters, I would be able to go to my quarts. Okay. So it's, again, 2-step problem. So we would place 30 milliliters. I then would put my milliliters on the bottom, liters on the top. I want to get rid of those milliliters and leave liters. I then set up another step, liters on the bottom, quarts on the top. I'm going to fill in, again, the metric ones we've memorized, so I know that 1 milliliter is 10 to the negative 3rd liters. And then here, 1 liter is 1.057 quarts. Again, when I plug this in, I'm going to multiply across the top, divide by the bottom. So 30 times 1 e to the negative 3 times 1.057, and we end up with 0.03171. With sig figs, again, there's infinite here, only 3 here. So your answer should have 3 sig figs. Again, I don't count those zeros, those leading zeros, so my answer would be 0.0317 quarts for my final answer. Now, we can also use this same concept when we're dealing with things with raised powers, like centimeters squared, centimeters cubed. We essentially are going to attack it the exact same way, where we assign, we define what the conceptual plan is, we assign the units in the appropriate places and fill in the numbers, but then we're going to take the entire conversion factors, not just the unit itself, but the entire conversion factor and square it or cube it or apply whatever appropriate power. So for instance, if we're going from inches cubed to centimeter cubed, we would start off by saying, well, there is 2.54 centimeters is for every 1 inch. But when we cube that entire thing, I'm not just cubing the unit, I also have to cube the number. And so I have to physically change that number to show the proper equivalence. And then I continue on the same way we've done before. Okay. So in this case here, we're going from 5.70 liters to cubic inches. So again, let's think about the conceptual plan here. We need to go from liters to milliliters. Then we can go from milliliters to centimeters cubed, and then from centimeters cubed to inches cubed. Okay. And so if that's the case, starting with the beginning, 5.70 liters. First, I would put my milliliters on the bottom, and first I would put my liters on the bottom, milliliters on top. Then I'm going to go from milliliters to centimeters cubed. I know a relationship between those. And then I'll be going from centimeters to inches, but it's that whole conversion that will be cubed. And so now we're ready to fill in our numbers. We know that 1 milliliter is 10 to the negative third liters. We know that 1 centimeter is the same thing as 1 milliliter cubed. And we know that in 1 inch, there are 2.54 centimeters. Now, before you put this in your calculator, go ahead and cube that 2.54. So 2.54 cubed, that's where we're gonna get 16.4, which is gonna go in our calculation, okay? So now we're ready to multiply across the top, which is a series of ones, so 5.7 times 1 times 1 times 1. Now we're gonna take that 5.7 divided by 10 to the negative third, divided by 16.4. And we get an answer of 347.5609, etc. With only 3 sig figs, again, we're going off of here, we would say 348 inches cubed is our final answer. Go ahead and check yours. I hope this video helped you understand all about given and find, or this dimensional analysis system, and you have the confidence to be able to apply it in future problems. Stay tuned for more videos related to Gen Chemistry. See you guys next time. Bye.